Okay, I've got a problem up on the board here, and it turns out this is another initial value problem that we just need to interpret a little bit. Okay, so an object is going to be thrown straight up from a bridge, and the bridge is 160 feet from the ground. Okay, the initial velocity is 48 feet per second, and I'm telling you that up is the positive direction. So I'm not throwing it down, I'm throwing it up with an initial velocity of 48 feet per second squared. Oh, sorry, feet per second. Okay. Now, the acceleration due to gravity, which is what's going to cause the object to come back down, is negative 32 feet per second squared. Okay, units for acceleration are units for distance divided by units for time squared. Okay. Now, this is a constant that those of you who've taken physics might be very familiar with. It's going to show up in a number of the homework problems. I don't expect you to have it memorized. Some of you will, some of you won't, doesn't matter. On exams, I would give it to you. As you're doing the homework, it's in your textbook, so you can just look it up. Okay. Do be careful. This is feet per second squared. Some problems are going to use the metric system, in which case it's going to be meters per second squared, and then it's the same gravity, different units, so it's going to be a different number. It's going to be negative 9.8 in that case. Okay. All right. So I want to know how many seconds after the object is thrown into the air will it land on the ground below the bridge. So I am specifying, I'm not standing on the bridge and throwing it up so that it lands on the bridge. If this is the bridge, I'm reaching out over the bridge, throwing it up so that it's going to come down and it's going to land on the ground below the bridge. Okay, and I want to know when it's going to land. Well, I could do that if I knew what the position function was, because when it lands, that's going to be basically finding the time when the position is equal to 0. Find t when the position is equal to 0. That's when it's going to be on the ground. Okay. But I don't have the position function. I'm going to need to find that. So what I'm given is that the acceleration is constant. It's negative 32. Okay. And I'm given some initial conditions. I'm given that the initial velocity, so that would be the velocity at time 0, is 48. And I know the initial position as well, which would also be the position at time 0. I'm going to just declare time 0 to be the time that I throw the object into the air. Okay. And if I'm on this bridge that's 160 feet from the ground, it's starting 160 feet from the ground. Okay. Okay. And we are supposing, I guess, that I'm, sort of leading over so that it's the height of the bridge. I'm not taking into account the height of the person who's throwing it. Okay. All right. So I basically need to work backwards from the acceleration to find the position function so that I can set it equal to 0 and solve for time t. Okay. So I'm starting with the acceleration. I know that that was negative 32. That's going to allow me to find the velocity, because acceleration is the derivative of velocity, so velocity will be an antiderivative of acceleration. So I can say this is going to be an antiderivative of negative 32, and I'm integrating dt because these are all functions of time. Now that's just a constant, so I'm going to get negative 32t plus, I'm just going to write c1, because I know I'm going to be doing this twice, so I'm going to get a second constant at some point. Okay, so this is the family of functions where I know that the velocity of this particular object is one of the members of this family. I'd like to know which one, and I can figure that out because I can use this initial condition. So I can say 48, that's what I get when I plug in 0. But when I plug in 0, I get negative 32 times 0 plus c1. Well, that simplifies to 48 is equal to c1. So I'm able to say v of t, my velocity, is negative 32t plus 48. So I've got my velocity. Now I want to try to find my position. So I can say position Well, again, the relationship is that velocity is the derivative of position, so position will be an antiderivative of velocity. So I'm going to integrate negative 32t plus 48 with respect to t. So that's going to give me negative 32t squared over 2 plus 48t plus c2. I'm going to use c2 so that I don't think it's c1, which I know is 48. This is going to be a different constant. Okay. And I can simplify this. The 2 and the 32 will cancel, so I get negative 16t squared plus 48t plus c2. Okay. Now, I'm going to use this initial condition. So let me just write down what I've got. P of 0 is 160. And let's remember, I want to find the time when this object lands. So 160 is what I get when I plug in 0 to my position function. But that's going to be negative 16 times 0 squared plus 48 times 0 plus c2. Now, when I plug in 0, these terms drop out. Do be cautious. In the last example we did in the last video, we were plugging in 0 to cosine, and that didn't drop out. So don't assume that everything's going to drop out when you plug in 0. And sometimes your initial value might not be the position at time 0. It might be the position at time 5. So then I'm not expecting things to necessarily drop out. In this case, they do. So I get 160 is equal to C2. So now I can put those pieces together, and I can say position is negative 16t squared plus 48t plus 160. Okay, excellent. Now, it's tempting to think we're done because we've found our function. Always a good idea, especially with word problems, to go back and reread the question at the end and make sure you've actually answered the question. Now, I've erased the question, but I remember what it was. It was, when does this thing land? So we were supposed to find the t value that would make this 0. So I'm going to take negative 16t squared plus 48t plus 160, and I'm going to set that equal to 0. I'm going to factor out a negative 16. Factoring out a negative, because with a quadratic I prefer my squared term to be positive, and 16 goes conveniently into all of these numbers. So this is going to be t squared minus 3t minus 10 is equal to 0. So now negative 16 times t minus 5 times t plus 2 is going to equal 0. So one of these things is 0. It's obviously not the negative 16. So either t minus 5 is 0 or t plus 2 is 0. So either t is equal to 5 or t is equal to negative 2. Now at this point we have to turn on our common sense just a little bit. How many times is the object going to land? Once. So we were looking for one time. So only one of these is the right answer. One of these is what we call an extraneous solution. It's a solution to this equation, but it's not a solution to the problem in the real world that we were modeling with this equation. So I'm noticing that this time is positive and this time is negative. And I'm thinking that my object is going to land after I throw it into the air rather than before I throw it into the air. So basically, if 0 was my starting time, this is the position function in between 0 and the time that the object lands. So I'm going to reject the negative answer, and I will just say it will land 5 seconds after thrown into the air, after it's thrown into the air. Into the air.